Hello, welcome again to drawing logarithmic graphs. This is the second part of drawing logarithmic graphs. This one here, we're actually given a graph with 3 points on it. The points we can actually just read off the axes themselves, but I've actually labelled them here just to make them a little bit clearer. Right, now this graph here has actually got a number of transformations with it, which we can start going through, and we'll start analysing them first. The first one is along these y-axes here, we'll see that our asymptote has remained the same, therefore it has not been horizontally translated either to the left or the right. That means that there is no translation in there. Okay, so that we know that it is y equals some base of x plus or minus something, which is going to give our vertical transformation. Okay, so we know that there is no horizontal transformation. First thing that we look for then is whether or not there's been a vertical, a shift up and down. Now typically from your asymptote you would go one across. This one here from the asymptote has actually not gone one across. From the asymptote it has actually gone two up before I hit one across. Therefore, I suspect that the function has actually been vertically translated up 2 units. Next thing I want to start looking for is I want to start looking for the base of the function. Now I know the base of the function, if I actually start from wherever my y asymptote is, if I go from there, if I count across, usually up until it hits 1. But because this has actually got more than one translation on it, we're going to go across until we actually just hit a integer value. So when we go across, we notice that when we go across to 3, we have an exact integer value of 6, and when we go across to 9, we have an exact integer value of 10. This is starting to suggest to me that this is log base 3, because we get integer values at 3 and again at 9. Okay, so the next thing that we have to think about then is, okay, this is y equals log base 3 of x plus 2. There's no horizontal translation, therefore there must be a constant in the front. Because normally I would have expected, if this whole thing was plus 2, I would have gone up 3, up 1 here, so it would have been 3, 4. It's not that, it is actually 3, 6. So therefore it's actually gone a lot further up than I would have expected. Right, this one here also, I would have expected this one here. Normally, again, if that there was taken as my x-axis, because I vertically translated up 2 units, I'd have expected that to be 9, 2. I would expect if it was a normal that hasn't been moved up, this one's been translated up, it's now at 9, 4. That you would expect with the translation going up. However, it's all the way up at 910, so there must be a number that's actually in front. Right, this distance here that has actually gone up is 2 units. That's what you're expecting. However, this one here has gone up from 2, it's actually gone up 8 units to take it all the way up to 10, so it's actually 4 times bigger than what you're expecting. This one here has actually gone up 1 is what you're expecting. You're expecting it to be there at this point here. However, this one here has actually gone up 1, 2, 3, 4 points. Therefore, it's 4 times bigger than what you're expecting. Therefore, let's have a look. We can actually hover over the top of it. It actually tells us what this is. This is actually y equals 4 log 3, and remember it does that funny thing with the 3 there, that actually that little line with the 3 means base 3 of x plus 2. Okay, well that was just one example. I will go on to some further examples in some other videos. Thank you.